I work as an associate professor of environmental science at the medical faculty of the University of Rijeka, and I'm also the leader of the Croatian node of Pixel. Together with my team of researchers, I am in charge of leading the development of the Port Environmental Index. In this brief video, I will present the baseline logic behind the index, the methodology that will be used to deploy the index and create the index, and also the benefits to the port of its deployment. So let's begin. The shipping industry in general, and port activities in particular, can have significant adverse effects on the environment. For example, the ports rely heavily on a wide range of machinery that run on diesel engines, which emit several pollutants into the atmosphere, including greenhouse gases, particulate matter, nitrogen oxide, sulfur oxides, and other chemicals that have the potential to cause serious adverse effects to both human health and the environment. Because of this, many communities have raised concerns regarding adverse environmental and health outcomes that they are experiencing due to exposure to emissions that are related to port operations. Although ports are required by law to monitor and mitigate their effect on the environment, a comprehensive, standardized methodology that would leverage the information technology in general and IoT technologies in particular to provide information on the environmental performance of a port is currently lacking. Thus, the scope of the Pixel project is to bridge this gap and leverage the IoT technology to improve the environmental performance of small and medium-sized ports. To that aim, we will use data obtained through IoT data sources and couple them with several modeling algorithms to optimize port operations and reduce and mitigate environmental impacts. To our knowledge, Pixel is the first project that leverages IoT technology for the mitigation of environmental impacts in the port domain. The effect of optimization procedures on the environmental performance will be assessed using a metric called the Port Environmental Index. The Port Environmental Index is a composite indicator of environmental performance which integrates all of the environmental impacts into a single value, calculated using data coming from different IoT data sources. Why we have decided to use a composite index of environmental performance? Environmental problems are usually multidimensional, and it is thus very difficult for decision makers to act based on environmental data that come from a large number of different data sources. It is much easier for them to act on complex environmental issues by addressing a single metric, which integrates all of the environmental impacts that a port is having. The Port Environmental Index is that metric. The indicator is being built using the following steps. First, all of the significant environmental aspects of port operations and their impacts are identified based on the information gathered from the Pixel pilot ports and available state-of-the-art technical and scientific literature. In the second step, for each significant environmental aspect, a set of representative indicators of its impact, the so-called environmental key performance indicators, or E Kpis, are identified. The E Kpis will be obtained using IoT data sources, by direct measurements, or by using proxy indicators. To be able to integrate all of the E Kpis, they will have to be adjusted to a notionally common scale. This is the third step, and it is a statistical procedure called normalization. Several normalization algorithms will be tested under Pixel to choose the optimal one in terms of robustness and ease of application. Not all of the E Kpis are equally important. Thus, the fourth step will include weighting of the E Kpis. Weighting is a very important procedure and probably the trickiest one to perform. In the literature, there is no agreement on the methodology for weighting individual indicators. Due to the nature of the problem, likely no consensus will ever exist. The process of weighting is an inherently subjective procedure, and thus selecting appropriate weights is challenging. However, several procedures can be used to make the weighting process as objective as possible, and they will be tested in Pixel. In the project, we will make every effort to make weighting assumptions crystal clear and fully transparent. The next step is the aggregation procedure. Several methods will be tested, including additive aggregation methods, geometric aggregation methods, and non-compensatory methods. Finally, a sensitivity analysis will be performed to test how sensitive the Port Environmental Index algorithm is to the input data. In this way, it will be possible to identify the data that affect the index the most to ensure that their accuracy is the highest possible. Also, In case there will be missing data in the data sets, we'll test several different methods for data imputation, including implicit and explicit modeling approaches. It is important to point out that the real value of the port environmental index does not come from the algorithms that will be used to deploy it. The fact that it will be built on IoT data sources and will enable the assessment of environmental impacts of port activities in real time is much more important. If we will be able to successfully address the automation of the procedure, it will be a breakthrough in the environmental protection domain. Therefore, we consider the development of the port environmental index leveraged by IoT a high-risk, high-gain segment of the Pixel project. How will the shipping industry profit from the port environmental index? The metric will be a useful tool for assessing trends in the overall environmental performance of the ports. By using the metric, the ports will be able to address whether they are making progress in terms of their performance or they are deteriorating. Since the index will be leveraged using IoT technologies, the information will be provided through a dashboard in real time. Thus, by using the index, the ports will have immediate feedback on the environmental effects of their operations and will be able to take instantaneous corrective actions to mitigate adverse environmental situations. Using current approaches, comparing the environmental performance between the ports is unfortunately not possible due to a lack of a standardized practice. To that aim, the methodology for calculating the index will be fully transparent, and we hope it will be widely adopted. By using the metric, it will be possible to make inter-port comparisons and rank the ports based on their overall environmental performance. Also, in the case that the ports will decide to disclose the index to the public, they will be able to showcase their commitment towards a sustainable and environmentally friendly management of their operations. Finally, the metric will enable the ports to address what-if scenarios and assess the environmental return on financial investment. For example, let's suppose that the port decides to invest in energy-efficient lighting. By using the index, it will be possible to quantify the effect that such an investment is having on the environmental performance of the port. If it does not affect the index much, there is no environmental benefit to be gained, and there are maybe other ventures that are providing more environmental return on investment. In conclusion, the Port Environmental Index will be an IoT-leveraged, comprehensive indicator of the environmental performance of a port delivered in real time. By using the metric, the ports will receive immediate feedback on the environmental effects of their operation and will thus be able to take instantaneous mitigation measures. Finally, the Port Environmental Index will be also useful for the ports to assess environmental returns on financial investments.